Hello, I'm JW, and today an update on the drill. Now I've dismantled the whole thing as we saw previously, and I've actually put the primer and undercoat on as well. So all that's remaining is just put the top coat on, hopefully tomorrow, and then we'll see the final colour. And I'm just going to have a look at the actual starter from the drill, which is basically the on-off switch, but it has a other function as well. And we're not actually going to be using it because it happens to be in a rather poor state, and it isn't actually the right kind of thing either. So here's most of the main components, and you see they're all fairly painted up now in this sort of grey matte finish, which is just basically a primer type of undercoat. So there's the motor, the main casting there, and then the couple of other bits around the back there. This is the table, and I've actually filled in the holes here where somebody had obviously drilled it in, destroyed it over a period of many years, so that's been filled in with basically epoxy filler. So obviously it's still visible, but it's a lot better than having all those gigantic holes in it. And again, that is actually painted grey on the back as well, and you can see some of those holes did actually go right through the material, so all that filled in there. And the main column and the base is actually down here on the floor, so again that's been painted in the same grey primer. Cleaned up the column, came up reasonably well, and of course the front is in bare metal just as it would have been when it was manufactured. Unfortunately I couldn't actually get the column out of the base. It seems to be voluntarily seized in there, so it can stay in. So not critical to remove it, and unfortunately because the base is cast iron, if you go hammering on that there's a very good chance of it cracking in half, so you can basically stay in there, not a huge problem. Now this is the starter, and it was basically on in the middle and just off at the top corner. This is pretty old, probably 1950s or maybe 60s, but certainly not much after that. It's an MEM, or Midland Electrical Manufacturing. The label is long gone, and Startet is the sort of brand that they used on those. Now we're not going to be using this because aside from its horrible rusty condition, it's actually pretty much destroyed inside as well, and on top of that it's actually the wrong kind of thing anyhow, so definitely not going to be using it, so we'll have to buy a new one. So we'll have a look at this inside and see basically how it was actually supposed to work, and why we're not going to use it, and its major downfall. Now this is the starter. I'd say it's pretty old, probably 1960s or maybe even older. Cast iron case, so extremely heavy. This wiring here was totally inappropriate. This is actually twin and earth, as in solid core, normally what you use for fixed wiring. It's certainly not suitable for this. And no, there's no grommet or anything here, it's just been shoved through the hole directly. They have at least attached the earth to the stud here on the side, but that's pretty much irrelevant considering the state that this is in. And this is actually 2.5 square millimeters as well, which is actually far too big for even this size of motor. And of course that was also shoehorned into that terrible plug we saw in the other video. Now the deal with this is that there should have been a plate here indicating the rating, and that's of course long since faded and gone. There was also supposed to be a little thing there with MEM printed on it, but that's also gone as well. And we've got this remains of this blue paint. Quite frankly, why it's only those bits there is a mystery. I get the impression this was black originally, and this is just a bit of paint spilled from some other unrelated item. Now the deal with these is they're actually a switch for starters, which is basically on there and then off up there. So of course that's how you turn the thing on and off. And if you have a look inside, the on button is just this thing which goes through with a screw on the back, so nothing too surprising there. Bits inside there, there's a label there, we'll attempt to clean that up and maybe read that later. And then the insides here, we can see, again it's in a fairly poor condition because there's several bits missing. Basically when you press the on button it's pressing this plastic piece down, and that just latches under this bar here, and then the off function is basically just lifting that up, which of course means it springs back, so on and of course off. So that's fairly straightforward. And the contacts, we can hopefully see in the back here, it's basically these curved bits of metal with a spring, so that when it's pressed down it essentially joins the contacts here and here together. So basically it's just bridging across those two. Now the way that this is supposed to work is that the switch is just turned on manually of course, and when the power goes through it will go through these heating coils, and these are selected with a particular current in mind, so the normal running current of the motor will cause these to heat up, but not enough to actually trip the mechanism. And then if the motor was stalled or some other misfortune occurred, the current draw would be increased. These would heat up more, cause these things here to bend, either one or all of them. And when these actually bend a certain amount, then it will open the contacts and disconnect the power to the motor and avoid it setting on fire or whatever. Now unfortunately this one is all bent out of shape, so that's not going to work too well. This one also isn't level with that one, so not in very good order. And we can see here on the top that all of the insulation on the coils, which may well have been asbestos at one time, has basically crumbled away and disintegrated. This one's all sort of crunched up in a mess, so that's not going to work properly either. So we're not going to be using this because obviously you can see it's in a bit of a state. There's also got bits missing here, and there's a screw gone here. And if you look at the top here, there's actually a massive chunk been broken out of the case, and someone has bolted on this additional piece to cover up the massive hole. So definitely not in the best of condition, and therefore we're going to be buying a new one. And another major problem with this, which is also a major problem now, and might have even still been then, is that the fact that if you turn this on and then power goes through, if it's in a power failure, nothing will actually happen, and then when the power's turned on again, it just will continue working as if nothing had happened, and that's definitely not desirable. New ones, and in fact even old ones, will have what's called a no-volt release, so that when you switch it on, the power will flow, but if there's a power failure, it will automatically open the contacts, and it won't restart until someone actually comes along and specifically presses the start button. And unfortunately this is not one of those, so there's another reason why we're not going to be using this. Now because this won't be used, we may as well just take it apart fully and see exactly what's inside, and just take these screws out. We should be able to remove the internal mechanism. And when you would have bought this, and in fact when you still buy the new ones, you do buy them with a specific rating of motor in mind, and the idea being that the actual normal running current is the thing you're basing this on. And the reason we have these is because if you just have a thing that trips out over a certain amount of current, like a circuit breaker, then it won't work with a motor, because when a motor starts it draws significantly more current than when it's actually running. And the idea of these being a thermal arrangement is that if you have a very high current for, say, a very short time, a few seconds, it won't be long enough to cause this to heat up to any kind of degree. So these will only trip if it's overloaded and it remains in that condition for a certain length of time. Otherwise it would basically trip out every time you turn the thing on, which of course is not what you would want. So let's just see if we can get this out of here. Probably going to have to remove the actual wiring as well. So this is totally inappropriate wiring. So the wrong kind, and it's also far too big. Now the motor doesn't actually have any kind of rating plate on it, but it's probably around a half horsepower or so. Maybe a third, although it looks a bit big for a third, but of course you never know with these old things, they were tended to be rather overbuilt anyway, so we'll obviously check the current and things on that at a later time. But running current on that you would expect to be in the region of sort of 5 amps or something, so nothing too terribly substantial with that. So we'll just remove these screws for the actual wiring. It's notable someone actually did bother to make little loops on the end of these and make some reasonable effort to fit them in, and that was the same on the motor itself. I really don't know why they bothered, but there we go, and it's just easier to get the correct cable. So nothing in the bottom really, it's just a metal case with the squeaky stop button installed. That is kind of red, and probably was red on the front until it got covered in grime. It's just a cast iron box with screws. So here's the actual mechanism. So an insulating sheet on the back, it's some kind of fabric-y, plasticky type material. Don't know if we can get any kind of information on the back. No, it just says made in England, BS54, so not a lot of help there. And you see there's a screw missing here as well, and then there's a big chunk out of the ceramic there. Obviously it's been subjected to very arduous conditions before. So you see the contacts in the bottom here, so it's only just one side there, and the other side over there. And then this piece is on a spring, and the idea being that when it's pushed against those, then the spring will provide a decent bit of tension there. All three are the same, so when it goes down there it makes contact, but then as you press it in, the spring make sure it's pressed firmly against those to ensure a good connection. And it's a very light mechanism here for the trip. It's just a mechanical notch there that just clips under that and can just be released by either these thermal bits here or the button itself on the top. Now these things will be the heating coils. They're going to be very low resistance, Bearing in mind these are actually put in series with the motor, so obviously you wouldn't want a high resistance there, otherwise the motor wouldn't actually operate properly. Let's just see what kind of resistance those actually are. Now if we just measure these leads, so the leads are basically 0.1 ohms, and if we just measure across one of these, say from here to here, so 0.6, so we're getting about half an ohm for the heating coil there. Again, if we just go in there, and that seems to be shorted, but unfortunately that's the one with the mashed together business on the top, so no surprise there. Just check the other one here, and again it's about half an ohm, so the outer two are okay apart from this bent and twisted business here. This has been basically crushed, so it wouldn't obviously work properly, and then this one theoretically would actually operate. And really that's pretty much all there is, so it's just literally 3 wires at the bottom here, though one is missing, contacts in there which are pressed down by the bar, heating coils, and then the 3 contacts at the top. And so you can use this for 3-phase or single use. 3 would just be phases 1, 2 and 3, and in the case of a single phase it would just be line and neutral on any 2 of these contacts. Now, so I'm not going to use it obviously because it's in the right state. The new ones actually work in a very similar way. Again, it's a thermal arrangement, so you've got basically a heating coil and a thing which will trip the actual contacts. And the difference on those is that they have the no-volt release, so that if it's in the on position, power fails, then it will trip and disconnect, so it doesn't automatically start up when the power is restored. So you wouldn't want it, for example, if there was a power failure and everybody, say, went home or something, and then the power comes back on and hundreds of machines in a factory suddenly start up and operating all by themselves, so clearly not desirable. And the other thing as well, if the power had gone off, or say a fuse had blown or something in the plug, you don't want the thing to instantly start up just when you've reconnected the power to it. Now here's the label, just removed it from the case there. A bit of a bad state, but we can just about read what it says. And as it says, this switch has 2 current settings only. The movable clips on the trip blades must be moved out for maximum and pushed in for minimum. Switch trips are approximately 25% above rating. Unfortunately, we don't know what the rating is because that presumably would have been on the front where the obviously plate has been removed. And then there were some other instructions here at the bottom which are unfortunately pretty much gone. And on the thing itself, it's basically these bits which can be moved in or out to determine the actual tripping current, so pressed in and pulled out. This one's now fell off, that was one that was all twisted, and there it is, busted and broken. So that's pretty much it for this time, and if you want to see any more pictures of these, I have put some of these on Instagram, Facebook and Twitter, so have a look at those. Links are in the description of the video. But until next time, thanks for watching.